Krankenwagen.
How do you find the base graph? So take away all the little transformations, look for the x, and what base is it attached to? 2. So the base graph is just going to be 2 to the x. Right? Exponent, what base is it? 2 to the x. So let's draw that first, and then we'll talk about the transformations. Not red pen yet. So in theory, like we looked at yesterday, you could take the table of values and you could do all those 5 points. I don't. I care about 2 points. I care about when x is 0 and when x is 1, because everything else is going to fall from that. What happens with any exponential function when x is 0? It's always going to be 1. Why? Why is anything to the power of 0, 1? Yeah. So the base graph is always, always, always going to have a y-intercept at 1. Always. So that's the point I always draw first. No matter what the base graph is, I put in 0, 1. Then all I really care about is when x is 1. So what's 2 to the 1? Is going to be 2. On the left-hand side, what do we know about the points? What's happening on the left? It approaches the, because there is a horizontal asymptote. So I don't care what these values are. I just know they're going to come from the negative side. They're going to be really close, and then they're going to pass through those points. What happens after that? I know it goes straight up. So when I graph exponential, I only do 0 and 1 because everything else is just going to fall from there. Then we'll put in our horizontal asymptote, which we know is on the x-axis. What color are asymptotes? Pink, orange, blue, black with a note that this should be red. Yeah, and the asymptote. Mm-hmm. Mm-hmm. Now let's talk about our transformations. This little 2 way up here in the exponent. What is he? I heard a really quiet x over 2. What's the minus 4? Grabbing my red pen because I'm going to make a note. Note. With any VT, VT stands for? The HA will also move. With any VT, vertical translation, the HA, horizontal asymptote, will also move. If you're picking up the graph and moving it, you're moving the asymptote with it. Correct. But we're going to do the HC first. If you're a point person, you can work right from these points. We're going to take the x's and divide by 2. You can't see that. So 0 divided by 2. 1 doesn't change. 1 divided by 2. 1/2, and the 2 doesn't change. So 0, 1 stays exactly where it is. 1/2, 2 is going to just come in towards the x-axis, or y-axis. Did we squish that in horizontally? Did we take the sides and squish it? Last step is just to move it down. I always start with the asymptote. If the asymptote is at 0 right now and we're dropping at 4, it's going to end up at negative 4. Zero, 1 is going to drop by 4, and our 1/2, 2 is going to drop by 4. Still approaches the asymptote on the left, and then goes up towards infinity on the right. Do you see the link to Unit 3? Yeah. Right? The only thing we've done is just done a different base graph. Everything else is exactly the same. How do you know this is exponential when you look at the graph? because it's got that swoopy shape upwards, exponential. Domain. We got an XER thrown out here. Agree, disagree? Y is greater than -4 we got for the range. Why not or equal to?
Because -4 just happens to be an asymptote.
It does happen to be an asymptote. Question so far. Number 4. Base graph first. So find the x, find the base it's attached to, ignore everything else. A half to the x. Again, you can do regular table of values. I tend to just take the 2 points because it's easier. 1/2 to the 0. Anything to the 0 is 1. 1/2 to the 1. 1/2. So 0, 1 is always going to be a point no matter what the base graph looks like. Here we have 1.5, so half a box up. Bless you. Well, we started this talk yesterday looking at the 2 shapes. One when the base graph is a whole number, one when the base graph is a fraction. What does it look like when the base graph is a fraction? Yeah, it swoops the other way. So it's going to come from the right-hand side this time, approach those 2 points, and go up towards infinity. Meh. As long as you got the arrow on the end, really, mathematically, it doesn't matter. Questions with this fraction base graph? Turn and talk. So find someone who looks friendly or doesn't look friendly and discuss the transformations. The little negative hanging out front here, what is he? I know what you meant. Agree, a VR? Not if it, oh, vertical, ooh. Yes, good job. What's the 4 up in the exponent? Horizontal something. Translation. 4 to the right. Why is it to the right? Perfect. If you're a point person, we can just come to here to do the vertical reflection. 0, 1 would go to 0, -1. And 1, 1/2 would go to 1 and -1/2. So we're just flipping it over the x-axis. So the question above we talked about with a VT, how that asymptote is going to move. What about with an HT? Why? Because we're moving sideways, so I'm just counting now and moving this guy 4 over. Oh, thank you. Turn and talk again. Figure out the domain and range together. Thoughts for the domain? I think you meant X, but I know what you mean. Cole, what you doing? Staring at your crotch or staring at your phone, either way. Range? There's the offer, y is less than 0. How are we feeling so far in the graphing?
Pretty good.
Oh, the word problem. Here's an application of exponential functions. Read to read. Don't overthink it. Just read it like this is a sentence in a book. It would be a very, very boring book. Well, this is what scientists do with what's called exponential growth. What do the mathematicians care about? I care about this formula, and I care about what the variables are defined as. So what I look through the question now is I need to find something about n and something about t. Where do we find information about n? It's the number of hosts, and it's in millions. And what about t? As a mathematician, that is all I care about. I could care less if this was computers that were growing, if it was butterflies, if it was bacteria in a dish. I don't care as a mathematician. That's what scientists care about. So really all I care about is the formula and then what the question wants me to do. What does it want in A? This is giving us a domain, so it's telling us the x-axis is going to go from 0 to 20. What does it want in B? And is there some rounding instructions there we might care about? In C? I'm not going to get out paper for an example. I'm just going to kind of squish it in here because we're doing it on our calc. Okay, so using our calculator, let's graph it. Can you see my calc there? Is it too dark? Of course, now I've covered the question. Well, this is kind of fun. We can't tease the German twice in one day. That's not fun. Oh, you just totally were on YouTube. That's awesome. 7.4, bracket 1.59, bracket. How am I going to get that exponent up there? What? The caret, the hat, the exponent key, and then t, which is going to be x for us. Zoom. What do we pick for zoom? Okay, so let's rule out what we're not going to pick. Which of these are we definitely not going to pick? Trig is out because there's no trig function in it. Well, standard might give us to us, but we're dealing with big numbers, so maybe not. Zoom box, not so much. Okay, so we could do a zoom out. We could do a zoom fit. Okay, let's do a zoom fit and see what the calculator wants to give us. Well, that's kind of pretty. So can you see the exponentialness? I think that's not a word. Exponentialness of the graph. And now we just want to make sure that we're doing what the question asks, and the question has given us a domain. They have said what to set the x-axis at. So how do we go in and manually change that if the calculator gave us something different? Yeah, we go into Window, And it's just the x that the calculator or the question has asked us, so we're going to put an x min of and an x max of 20. Then hit graph. Oh, that's pretty. Oh, that is very weird. I don't know. Now it's white, pinkish. Maybe it's, oh. Might be my calculator it's picking up on.
Yeah, trying to adjust to it. There should be color adjustments too.
Typically on the exam, this would be a 2-mark question. You would get 1 mark for having the correct graph, 1 mark for having the correct domain that the question specified. Okie dokie, now what? So what is part B asking us for? Yeah, so it's giving us this equation, and typically it's telling you to replace one variable and solve for the other. Is this a t-value or an n-value? This is time, so this has to be a t-value. What are we trying to solve for? So we're trying to solve for n. So this is just a direct substitution question. I'm going to take out t and I'm going to put in 2010. So that's just a straight up calculator calculate question. Just make sure you do your rounding correct. No, they took it out of the curriculum. It used to be in grade 9, but then you guys do it in science, so we took it out. Do you guys do sig figs in physics?
Yeah.
Yeah, we do sig figs in IB math. I'm just reading what somebody's saying, so someone needs to verify this.
Mine says
Really?
Yeah, that's a big exponent. I thought you should make e to like a big number.
I think we need to get 15 in the exponent because it says after 19.
Oh, whoa, that's why. Thank you, Simon. Now I can't make fun of him because he was good today. Okay, what did we do wrong there?
We didn't account for
Yeah, see, because I didn't highlight it. Yeah, so not from year 0, from year 1995. So if we're going to 210, what should our exponent be? Good catch, high five. I barely remember life before the internet. Not going to lie. Barely remember it. It wasn't as good, though. Life's better now with the iPhones.
I remember when the elbows just came out and our teacher called it in elementary because we had one the whole school. And she was like, come on. Yeah.
So where is this coming from if you're probably getting 7.765 on your calculator? So you're probably getting right 7.765. So where is this coming from? Because that was billion, so to go to million, you've got to times by 1,000. That's where it's coming from. So we took our 7.765 times by 1,000.
I didn't get 7.765.
Oops, somebody want to confirm?
I got 7,765.
Oh, did it give it straight away?
Yeah.
Then just ignore me then. This is ignore me, that's not there. Adding the unit.
Years.
Hosts. Okay, what about C? Yeah, so how is B different from C? So how do I put in 1 billion? Okay. No, because this is in millions. So a billion is 1,000 millions. equals
7.59.
Does everyone get where the 1,000 came from? Okay. What do we do with this? Stuff, magical math stuff. Well, that's actually what this whole unit is going to be about, is how do you solve stuff like this? Because you've never seen when the variable's in the exponent. So that's what these things called logs that we're going to talk about do. That's what they're going to allow us to do, is solve this algebraically. Right now, we don't have a way to solve it algebraically. So what's our backup to doing something when we can't solve it algebraically? Okay, how do we solve this on the calculator? We have done this in radicals. We did it in trig graph. Well, okay. Okay, what do you want to do? So jump down and put in 1,000. And then graph. I don't see that line. Okay. So what do we want the window? 1,100 I heard was the offer. Okay, so I'm just going to add that to our diagram. Was our max, because we need it to be at least 1,000.
For X or Y?
Y. Now what?
That would be 2005.
2005.
Yeah, and we rarely count 0.5 when we're counting years. Questions? Because if it's 10 after 1999, so we added 10 years to get 2005. Should it be 2006?
No, 2005 or 20.
Yes. Yeah. But it says in what year. It doesn't say how many years from now. Homework is on the calendar. You got lots of time to work